class, and welcome to part B of chapter 2. This chapter was on chemistry, and we're going to kind of finish this PowerPoint off here. We're going to talk about chemical reactions make and break chemical bonds. So we talked about chemical bonds are the sharing of electrons, and chemical reactions will make and break these chemical bonds. The formation of water, for example, from hydrogen and oxygen, H2O, is an example of a chemical reaction breaking existing chemical bonds and forming new ones. The composition of matter is changed as bonds are broken and formed to convert reactants to products, and chemical reactions will never create or destroy matter, they only rearrange it in various ways. So fill in the blanks here with the correct numbers in the following chemical process. So what you're trying to do here is, and I think what you need to do is kind of put in the number of atoms that correspond to each letter. So if there's 6 carbons on this part of the equation, we need to make sure there's 6 carbons at the end of the equation. So everything before the arrow is called a reactant, and everything after the arrow is called a product. And I'm hoping they tell us the example here. And we'll kind of look at this one to show the example. If we take 2 hydrogen molecules, so H2 is a hydrogen, and we have 2 of them, and we combine them with an oxygen molecule, so 2 oxygens. So we have 2 H2, which is 4 total. That's why you see 4 little white balls there. 2 red oxygens we get by the forming and breaking of different chemical bonds, 2 H2O molecules. So the number of atoms equal on either side of the equation between the reactants and products, but things are just formed differently by the breaking and forming of those chemical bonds. So we'll talk about water's life-supporting properties because water is really important for a lot of different things. The tendency of molecules of the same kind to stick together is called cohesion, and the clinging of one substance to another is called adhesion. Cohesion is related to surface tension, which is a measure of how difficult it is to break the surface of a liquid. And after a workout, for example, you may notice beads of sweat on your face. And the reason why the sweats are in droplets that are forming on the face is because of surface tension. That there's a cohesiveness of those molecules to stick together. This is a look at how surface tension allows a water strider insect to walk on the water very quickly. And this is a great animation of water transport. And again, by now, I'm hoping you have downloaded these PowerPoints and are watching these animations as well. Thermal energy, so we're talking again about water's properties, and water's hydrogen bonds can moderate temperature. Thermal energy is the energy associated with the random movement of atoms and molecules. Thermal energy is transfer from a warmer to a cooler body of matter. We define that as heat, and temperature will measure the intensity of this heat. When a substance evaporates, the surface of the liquid that remains behind will cool down, and this is a process called evaporative cooling. And this is a checkpoint question. Explain the popular adage or saying, it's not the heat, it's the humidity. And the humidity refers to the amount of moisture in the air, which kind of measures the intensity of that heat. This is just a look at sweating. Kind of a cool picture. We just had the Super Bowl, so there's a football player there, but sweating is a mechanism of evaporative cooling. So it helps the body cool itself. Ice can float because it is less dense than liquid water. So water can exist or be a gas, a liquid, or solid. So solid as an ice, liquid as the water you drink or swim in or bathe in, and a gas as when it evaporates as steam. Water will be less dense as a solid than a liquid because of hydrogen bonding. And when water freezes, each molecule forms a stable hydrogen bond with its neighbors. As ice crystals form, the molecules are less densely packed than in liquid water. And because ice is less dense than water, it will float. Explain how freezing water can crack boulders. So because if freezing water gets stuck within the cracks of a big rock, that freezing water will expand and cause the boulder or the rock to expand or crack. So this is a look at hydrogen bonds between water molecules in ice and water. In ice, the hydrogen bonds are extremely stable, and you can see that here, these hydrogen bonds. And in liquid water, the hydrogen bonds will constantly break and reform. So that's what causes water to exist as a liquid, and then as an ice below freezing point. Hydrogen bonds between water molecules and ice and water. Water is also what we call the solvent of life, meaning many things can be dissolved in water. The word solution refers to a liquid consisting of a uniform mixture of two or more substances. Water's versatility as a solvent, meaning it can dissolve a lot, will result from the polarity of its molecules. So polar or charged solutes will dissolve when water molecules around them, forming an aqueous solution. Why are blood and most other biological fluids classified as aqueous solutions? And that's because solutes dissolve within them. So you have a lot of solutes in your blood, and a lot of solutes are things that can be dissolved in other biological fluids. So we classify them as aqueous solutions because things can dissolve in them. So this is a look at a salt crystal. So let's say we have a glass of water and we put some salt in the water. How does the salt actually dissolve in the water? Well, we have positive hydrogens attracted to the negative chloride ions, and negative oxygens are attracted to the positive sodium ions. So water, because of its polarity, meaning it's positive and negative on either side, will pull apart the sodium chloride salt crystal. When it pulls apart the sodium and chlorine, it will dissolve the salt itself within the water. In liquid water, a very small percentage of water molecules break apart into ions, and we use the scale to describe how acidic or basic a solution is. A buffer is a fluid or a substance that helps to minimize changes in pH. And compared to a basic solution of pH 9, the same volume of an acidic solution at pH 4 has much more hydrogen ions. So if a solution has a lot more hydrogen ions, it will be much more acidic. So this is a look at the pH scale. Extremely acidic solutions will be battery acid, lemon juice, gastric juice in your stomach, vinegar, Coke, tomato juice. Rainwater and human urine and saliva are getting more on the neutral side of things. And pure water is completely neutral. Human blood and tears are just slightly above neutral, about 7.4. And then seawater, and moving up to the basic side of things, household ammonia, bleach, and oven cleaner are all extremely basic. And you can see here the differences between an acidic solution, a neutral, and a basic solution. An acidic solution has a lot more hydrogen or H positive ions in it, and a basic solution has a lot less, whereas a neutral solution has about equal parts of them. And again, this just shows how water breaks apart into its different ions. And if you have more hydrogen ions, the H plus, it'll be acidic, and less H plus, it'll be more basic. So here's just another look at the pH scale, and it kind of breaks it apart, showing the two sides of it. The acidic, the increasing acidity has a higher hydrogen concentration, and the increasing basic will have a higher OH or hydroxide concentration. And those are the three different types of solution, and you can see where the hydrogen ions will be the most in the acidic solution. Carbon dioxide then, so scientists will study the effects of rising atmospheric carbon dioxide levels on coral reefs, for example. Carbon dioxide is a main product of fossil fuel combustion, so the waste from your cars, plants. It increases in the atmosphere and is linked to global climate change. About 25% of this human-generated CO2 will be absorbed by oceans, and carbon dioxide will be dissolved in seawater. It'll lower the pH of the ocean in a process known as ocean acidification. So basically, carbon dioxide will increase the acidity of the oceans. And that is because when seawater acidifies, extra hydrogen ions will combine with carbonate ions to form bicarbonate. And this reaction will reduce the carbonate ion concentration available to corals and other shell-building animals. So in a controlled experiment, scientists looked at the effect of decreasing carbonate ion concentration on the rate of calcium, and they found that the lower the concentration of carbonate ions, the lower the rate of calcification, and basically just the slower the growth rate of coral animals. So this just shows the carbonate concentration and the calcification rate, meaning more carbonate ion concentration, there will be more calcification, just meaning that sea corals will not grow as quickly, they'll be calcified. So these rising carbon dioxide bubbles will lower the pH of the water, just making it more acidic. The emergent properties of water support life on Earth and may contribute to the potential for life to have evolved on other planets is a theory. And from this checkpoint, these slides just show a checkpoint at the end of the chapter, what you should be able to do to kind of test yourself, to review, to make sure you know kind of these 8 main points of the chapter. Unit 1 shows the life of the cell, and we're going to go over this next. And we'll talk about the life of the cell as a medical technician, a brewer, solar energy engineer. These just kind of go through different pictures and kind of a good review slide pictures of what we already talked about. You can review on your own what makes up the nucleus, the protons and the neutrons with the electrons floating around. This again reviews concepts of liquid water versus ice, showing more stable hydrogen bonds in ice versus liquid water has hydrogen bonds that constantly break and reform. This shows connecting all the concepts. It's kind of a great, again, review slide taking you through what we talked about with atoms, chemical bonds, ions. So I'll let you guys kind of work through these slides on your own as a good way to review. And there's always notes at the bottom of these slides to kind of help fill in any blanks. So I would encourage you guys to use these review slides to kind of test your knowledge. And that is the end of chapter 2 for this week. Thanks for listening, guys.